Hi everyone, this is the video lab report for lab 1. These are the contents. Basically, we are measuring charge tapes and how they interact with each other by experiment and by modeling. And this is our purpose. We basically want to be familiar with charges and how to determine the x-axis charge. We also try to understand the effect of sign of charges when interacted with each other. These are the fundamental physics principles. The Coulomb's law is this one, and it basically models the amount of force given the charges and the distances. And here is the relation between the electric force and the electric field. Here's some brief preview of my results. These are the values I got for the charges. Here are some observations. This is how the tape attracts my hand and attracts a neutral book. And it repels a plastic pen and repels another tape as well. And these are some hypothetical questions. I answered them after them. And then according to my experiments, I found that since it repels a negatively charged pen, a U-tape is negatively charged. Here's my experiment setup. I use bottles to hold my tape above. This is the assumptions I made for the experiment. It's that the U-tapes have the same net charges. And the tape, I see them as single point charges that are located at the center of the tape. Here's my calculations. Basically, a mass is equal to the distance times the density, and I can calculate the charge by this, and it should be negatively charged since we got that result from our experiments. And the observations that we made are the length of the tape is 20 centimeters, and the distance that the tape began to float is 2.1 centimeters. These are some results, numerical results I got. Here's my code for part 1. And you can see that the green arrow is the electric force. They have the same magnitude but different directions. And also the gravitational force is the same magnitude with the electric force as well. Here are some questions. Since the momentum is not changing, the net force would be 0. And the only object that is exerting force is the tape below is exerting electric force on the tape above. And here's the force diagram for the tape above. And you can see, and in order to determine the gravitational force, I only need to measure the mass of the tape because by measuring the length of the tape. To get the ratio, we calculate the number of atoms, we measure the charge, and divide the measured charge by the amount of charge on an electron, which is this. And we divide them to each other, we get the ratio. The assumption I made is that the atoms are squares and they exist in a grid form. Here's the second part of my Glowscript code. You can see I scaled the values differently. Since the electric field should be very small, very big, I scaled them small, and the opposite for the forces. And as you can see here, the green arrows are the electric field, and the electric force is the white arrow, and the yellow arrow is the gravitational force. As you can see, those two arrows have the same magnitude. These are the results I measured for the different models and the assumptions that I made for both of those models. If they are reversed, not much would change. The only thing that might change is how the electric field, the direction of those electric fields, because we define them as how much force a positive charge would experience. But if we define them reversed, that might change to the opposite. And also, the reason that they're different is because the first one didn't account for the nature that the tape has a length. It models it as a point charge, and the second one should be closer to the real value because it actually takes into account of the actual shape of a tape. That is it for my lab report, and thank you.